morning, everyone. You're still up to another session today. So I'll be the last presenter for the last day for this particular hall, for this session. My name is Chemist Devi Annabelle Peter. I'm from Jetama Water Sdn Bhd and currently attached to the operation department. So today I will be sharing on this topic, also close to what have been presented by our two presenters just now, talking about treatment of wastewater and as well as the very important topic on environmental social governance, or in short ESG. So my topic today will be the potential reuse of water treatment sludge, or in short WTS, as a raw material in the production of eco bricks, which also cater to the E and S element in the ESG, the environmental and social element. So I will bring you through the session today. I will just first introduce you to our company, and then some introductions on this particular study, the problem statement, the potential solution, which is the single-step production of compressed stabilized earth block, or in short we call as CSSB, using water treatment sludge. And afterwards we will talk about more in depth on this particular study. We will touch upon the research introduction, research objective, the research methodology, the results and discussion, some conclusion, and what are we going to do moving forward. So just some introduction about Jetama Sdn Bhd. Okay, Jetama Water is part of the subsidiary in Jetama Sdn Bhd. So Jetama Sdn Bhd is a wholly owned company of the state government of Sabah through Kota Kinabalu Water Sdn Bhd, a subsidiary of Sabah Development Bank. That means we are a government-linked company in Sabah. And Jetama Sdn Bhd has been awarded a concession of 6 water treatment plants currently in Moyo, Kasigui, Telibung, Papar, Tamparuli, and Tuaran water treatment plants. So all of these plants are situated in the west coast of Sabah. So currently, all these 6 water treatment plants produce on average of 328 million liters per day for the supply of treated water to Kota Kinabalu, and also the surrounding water supply areas of Tuaran, Nampang, and Papar. So, why do we have this study? So, as a water players, or those who work in water treatment industry, you know that aluminium-based coagulant are widely employed in the water treatment due to their versatility and effectiveness in removing impurities. But despite its efficacy in water treatment, it generates a large amount of residual alum sludge, which is then discarded into the sludge lagoons. As a result, one of the main drawbacks of water treatment plant is sludge disposal, and necessitate a large footprints to store all this residual sludge before it is then further disposed according to the Environmental Quality Act, or EQ Act. So what is the problem now? As you can see, this is extracted from the first schedule, Regulation 2 of the Environmental Quality Act, Regulation 2005. What we have here, it's stated in the regulation that sludge containing aluminium will be characterized under the code SW204 as EQA 1974. So this particular code, sludges containing one or several metals, including chromium, copper, nickel, zinc, lead, cadmium, aluminium, tin, vanadium, and beryllium. So according to the Environment Quality Act, the disposal of scheduled waste stated that it must be disposed of at prescribed premises only, and as far as is practicable, be rendered innocuous prior to disposal. And the responsibility of waste generator to ensure that every waste generator shall ensure that scheduled waste generated by him are properly stored, treated on site, recovered on site for material of product from such scheduled waste, or delivered to and received at prescribed premises, as mentioned earlier, for treatment, disposal, or recovery of material or product from scheduled waste. So as you can see, this is the problem that we've been faced by all these water treatment company. Because you need to treat the water, you need to use the coagulant, but you will be left with all these sludges that need a lot of expenses to be dealt with. Some cost estimation on the water treatment sludge disposal or treatment. For our Moyok water treatment plant, in average, we produce about 185 million liters per day. And annually, if you want to dispose this in landfill, we have to spend around 3,000 ringgit. If we want to do some incineration process, we have to spend around 1.9 million ringgit annually. And mind you, this is only a cost estimation, and it can be higher than this. As for the Kasigoi sludge waste, producing 53 million liters per day, that is the average production, you can spend up to or minimum 100,000 ringgit. And for incineration, around 600,000 ringgit. And these examples only cater for Moyok and Kasigoi. Jetama produces around 530 metric tons of sludge annually, and the sludge management program incurs high cost to the organization. So what is the potential solution? We have a collaboration with Universiti Malaysia Sabah, collaboration between Jetama Berhad and UMS. I would like to honorably mention Professor Jidol from UMS. Please identify yourself. Just stand up. Okay, this is Professor Jidol, representative from Universiti Malaysia Sabah. So Jetama Berhad has taken the initiative to form a formal collaboration between Jetama and Universiti Malaysia Sabah in researching the potential usage of water treatment sludge as the raw material for eco-brick. So what is the solution? Based on this collaboration, we came out with a single-step production of compressed stabilized earth blocks, or in short, CSEB, using water treatment sludge. We actually have the prototype here. So pay attention. I might ask questions, and if you're able to answer my question, you will bring this back for free. Or probably a free supply of brick from Jetama. No, just kidding. Okay? So you might have a look, or those who have been to our booth. This is already been displayed there. So this is a real product that has been produced from this collaboration. So, some introduction on the research. The water treatment plants worldwide, as I had mentioned previously, face major environmental and logistical issues due to increasing sludge volume. So this problem is not something that only Malaysia faces. Regardless of the water treatment sludge being a non-scheduled waste or scheduled waste, we still have to deal with this sludge waste. So, for example, in Brazil, annually, they produce about 78 million tons of sludge. In Australia, about 3,000 tons annually. 131,000 tons annually in United Kingdom, and in Malaysia itself, around 5,500 tons of sludge daily. So recent attention has been focusing on repurposing this sludge for various industrial uses, including clay brick production, road construction, and manufacturing of compressed stabilized earth blocks, like what we did. So while some studies suggest that challenges in using sludge alone for CSEB due to insufficient fine contents, other propose minor substitution alongside traditional materials, but with reduced compressive strength. So in the production of brick, it is noted that one of the most important parameters is to ensure that the brick produced met the required compressive strength. So what is the research objective? The primary objective is, for this paper is to demonstrate. The key word here is the viability. Is it viable? Is it possible? Is it feasible? To utilize sludge from water treatment plant as the sole raw material for producing CSEB with sufficient compressive strength, as opposed to some previously written papers. So Professor Jidol has done a very good job here. So in this collaboration, Professor Jidol had helped Jetama a lot in ensuring that we are able to produce a product, an eco brick that met the minimum requirement in terms of compressive strength. So this research introduced a novel single-step method to utilize sludge as the sole raw material for SCEB production, eliminate the needs for multiple materials, enable cost reduction, and of course, like I said, addresses environmental concerns and promotes sustainability by fully utilizing water treatment sludge. And it represents a significant advancement in the production of compressed stabilized earth block. And most importantly, we aim to drive positive social economic impacts and environmental sustainability. Some information on the research methodology. It involved a single-step process using sludge from water treatment as the sole raw material, mix only ordinary Portland cement and water. So you only need 3 ingredients. You need the sludge itself as the primary ingredient. You mix it with some cement and water. But given the pioneering nature of this work, the test results are limited to the assessment of compressive strength. However, like I mentioned previously, it is recognized that higher compressive strength in this compressed stabilized earth block typically corresponds to better performance in all other required parameters. So this is the steps that are being employed to produce this compressed stabilized earth blocks. Phase 1 is for the sludge preparation, where sludge is being collected at our lagoons, and then the drying process ensued, where once collected, the sludge undergoing drying process via air drying method and to remove moisture contents. So this stage took the longest period. Why? Because if you want to employ any kind of drying method, for example, using oven or any drying machine, you might incur a lot more cost in terms of energy. And then we go to phase 2, where the crushing and the sieving process will ensue, where the sludge is crushed and sieved through a 1 millimeter diameter sieve. And afterwards, the mixing process, where, as I mentioned earlier, we have our cement, we have our sludge, and then we mix these two together. So our mixture ratio for this purpose, to be able to produce this CSEB, is in a ratio of 15:85. That means 15% of cement and 85% of sludge. So for the purpose of this study, we would like to go as much sludge as possible. Why? Because the purpose of the study is to see if we are able to produce this CSEB using sludge as the sole raw material. So the more sludge is being used in the mixture, the better. Afterward, we go to phase 4, where we did casting and compressions of the materials, where the mixture of sludge and cement is then conveyed to the feeder for more casting and compression afterwards. And the last phase, where we did curing and compressions strength tests. This bricks, so this is the bricks that will be set aside for a curing process, during which they are periodically sprinkled with water twice daily before strength tests are being conducted. So there are 2 periods where this compressive strength are being tested, and I will explain this on our discussions. Okay, some pictures where we have our open space drying of sludge samples. And then this is the finished interlocking CSEB. And afterward, this is the process of testing the compressive strength of said CSEB samples. Going to the results and discussion, as I said previously, we did compressive strength analysis for all our prototypes. So there are 2 curing days, the 14 days curing times and the 28 days curing time, where it is said that the brick will be fully cured in 28 days. So what is our required compressive strength? According to the British standard 3921, 1985, we required a minimum of 5 megapascal of compressive strength. And as you can see here, and this particular CSEB product is produced using Kasigui water treatment sludge. In 14 days, the compressive strength range from 3.451 to 5.458 megapascal. After 28 days, where the brick is considered to be fully cured, the compressive strength managed to be in the range of 5.527, with the highest compressive strength reported to be at 0.182 megapascal. We required only 5 megapascal, and our product are able to produce minimum of 5.527 megapascal. So what is the conclusion from all this study? The most important thing, as I mentioned earlier, we want to see the feasibility the viability of producing eco bricks using our sludge. So the CSEB produced using the single step method with Jetama sludge exhibit compressive strength meeting building construction standards, demonstrating the feasibility of this approach. So if our topic today is the possibility of using water treatment sludge as raw material for eco bricks, then this answers that question. It is feasible, it is possible, it is viable. The method offers a sustainable way to manage the sludge from water treatment plants, mitigating the environmental and logistical problems associated with sludge disposal. And this approach potentially reduces production costs by minimizing the need for multiple raw materials. That means if you want to produce this particular product, the CSEB, by only using sludge, cement, and water, we are able to minimize the need for other multiple raw materials. And will definitely reduce the financial burden of sludge management produced by the water treatment plants. And by repurposing sludge, the method aligns with the principle of circular economy, highlighting resource conservation and efficiency. And last but not least, the successful production of this eco brick using sludge as the primary raw material represent an innovative step in the sustainable material sector of the construction industry. So what are we going to do moving forward? Even though I did mention that using water treatment sludge is possible to produce eco brick. However, we have also encountered a problem where achieving consistent quality and properties in eco bricks made from sludge can be an issue. Why? Because of the variation in sludge composition, moisture content, and other factors. So moving forward, Jetama and Universiti Malaysia Sabah aims to ensure uniformity in the final product because it is essential for its structural integrity and usability. Therefore, the next step involves improving machinery and investigating other relevant methods. Who knows, maybe next year we might come with another topic where we can produce a more uniform and consistent product. As well as the regulatory compliance part, where compliance with environmental regulation and standard is crucial when we are dealing with sludge as raw material for eco bricks. Why? Because I stated in my problem statement previously, this sludge is all considered as scheduled waste under Environmental Quality Act. So we have done the application for special waste management to DOE and currently is waiting approval. And last but not least, of course, the public perception. There may be some skepticism or resistance from the public to use sludge-derived materials in construction due to concerns about safety, hygiene, and environmental impact. So educating the public and addressing this concern through transparent communication and rigorous testing is essential to get acceptance for sludge-based eco bricks. But in the meantime, in this initial stage for Jetama the emphasis will be placed on utilizing these materials for non-structural application. Possible application would be landscaping or garden application, non-structural building components, for pavement, paver, furniture or artistic application, as well as to serve as a basis for further education purposes. With that, I end my presentation. Thank you. Feel free to ask questions.